Good day, I'm Don Toot for Engineering TV. I'm talking to Ivan Chen from EPC. He's a field applications engineer. And we're here to talk about actually doing some development on your products using GaN. So, Ivan, what's different about why can't we just do it the same way we always did?
Well, Don, that's an excellent question. So with gallium nitride, we're seeing never before seen performance in terms of switching speeds than MOSFETs. So when you allow people to have these fast switching speeds, traditional MOSFET-based packages become a huge impairment because of inductance. And so ultimately, what we have here, EPC has very, very fast switching FETs, but to accommodate the fast switching speeds, our packages are all based on BGA packages or LGA packages. So MOSFETs are traditionally packaged in more like QFNs or CAN packs, etc. And those are very high package inductance. Also, secondarily speaking, the layout becomes very critical. And so to optimize the performance of our FETs, we pay a lot of attention to the layout. For our parts, we have development boards to showcase the switching capabilities for engineers to evaluate its performance in a very easy and convenient way.
All right, so these give you the opportunity to measure performance characteristics, but if somebody wants to go beyond that, create an application and see how these parts perform in their application, what do they have to do?
Well, each of these development boards are showcased in a half-bridge configuration. So if we want to zoom in here, there's different types. So there's the traditional single half-bridge, and we have these for different products. If you want additional current handling capabilities, we have paralleled half-bridges. And the reason why we parallel half-bridges is because the parasitic inductance on the PCB plays such a dominating factor in the overall paralleling loop that instead of paralleling FETs in the traditional way where we stack them in an array, we actually parallel full half-bridge circuits. So we cover different FETs in different voltages and different currents to facilitate ease of use. And if you actually want to demonstrate a prototype board or development board into a full-blown application board, here I have a series of different development boards in various states of rework to show how easy it is to go from a development board all the way to an applications board. So let's talk about how to turn a development board into an applications board. So just to quickly introduce what the nodes are on our development boards here, we have our VIN, our switch node, and ground. So on this board here, I've scraped off the solder mask on each of the 3 nodes, and the amount of solder mask that you have to scrape off is dependent on how much current you would like the buck converter to operate on. So given that there's a massive amount of solder mask scraped off here, this will allow for a large amount of current. So the next step is to add your passive components. So here we have our buck inductor. You'll see that it's soldered onto the switch node. But to isolate the other end of the buck inductor from the ground node on the bottom, we had to add a layer of Kapton tape. And on top of the Kapton tape, we have some copper tape, which connects to the output capacitors on this side. And to finish off the buck converter, all we had to do was add banana jacks for the input, the output, and also ground. Now, if you really want to be ambitious, you can use these devices and adopt something to be a standalone buck converter. So in this case, all we did was tie the board just previously shown and connected it to a controller from your favorite IC manufacturer. And what we did here was we tied the PWM input from the controller into our development board and also connect the feedback so that the controller completely controls the operation of our GaN development board. Doing so allows a complete standalone design for your application to not only experience the benefits you would get from using GaN, but also allows you to completely not have to worry about any dead time control or other design difficulties you may have.
All right, where do you go online to find out whom to talk to, what else you have to do to get these things to play with?
So EPC has done a fantastic job of publishing and releasing a lot of information. Everything is on our website at www.epc-co.com. There's design support, there's assembly guidelines, and a lot of various other information that would be important for an engineer to evaluate our devices.
Very good, thank you.
Thank you, Don.